In the previous video, I was not able to make the smaller FP4 model work, and the result generated was bad. This is not a guide for LTX. I will just be sharing my findings and resources found about the smaller FP4 models, with some test results, prompts for LTX, and a workflow for using audio files with an image to produce a final output. The FP4 model is not the regular quantized model. This FP4 has a different quantization logic. There is a detailed blog published by the NVIDIA's team. You can check if you are interested in the technicality. This model is smaller and faster than other larger models, and in terms of quality, some users said the difference is not noticeable. However, I think the differences are noticeable. The FP4 is better for a 5000 series card and had compatibility issues with older cards which resulted in a bad output. Now the support for FP4 has been added in the comfyUI. So I will be trying the same on my 4060 Ti 16GB card. Make sure you have updated comfyUI using this batch file which is inside the update folder. In this text-to-video workflow, I'm using the FP4 model, and I was able to generate a 720-pixel video. The time it took to generate the first result was 368 seconds.
It's raining, I love it when it's raining.
The quality of this video is not good. I will try a few more prompts. I tried the FP4 model in this image-to-video workflow, and the subject here looks acceptable. But you can see the fast motion made the background and her dress pixelated.
Welcome to Rosie's. What can I get for you today?
This is incredible. The light is perfect. Keep pushing. We're almost at the ridge.
This text-to-video looks interesting, but the other people cycling at distance are disfigured and fading away. So that is the LTX workflow for audio-video upscale models. The video generation time it takes is around 300 seconds. And these disfigured objects and characters should be fixed to some extent after we get some trained LoRa. With the FP4 checkpoint, I have selected this FP8 text encoder, and the text encoder was downloaded from here. The next files are these LoRa and an upscaler. The LoRa is already given in the workflow, and below is the upscaler. One step takes around 10 seconds, and you can decrease the steps. Some users are keeping it 15, which also works. This time the generation time was around 300 seconds, and a video with slow camera movement produces a decent result.
Welcome to Rosie's. What can I get for you today?
It is not clear and sharp, but I am sure that is achievable once people start training LoRa. In the workflow, there are these LoRa loader nodes, not in use right now. I will try and see if it works, or I get a memory error. I will pause this and run the workflow again. So there is no such noticeable delay in the video generation steps. And this time, the time taken to complete the video generation was under 300 seconds, but still around 300.
Welcome to Rosie's. What can I get for you today?
I do not see any difference in the output. As mentioned about the LoRa details, the camera control LoRa can move the camera towards the specified destination. In this case, it goes closer to the subject smoothly. The previous prompt we saw, it said the camera glides along the group, and then it pulls backwards to show the surroundings, which did not happen. I tried again with the LoRa. The video generation time was around 330 seconds, and I see the camera movement happening.
This is incredible. The light is perfect. Keep pushing. We're almost at the ridge.
The prompt was, the camera occasionally pulls back to reveal the full expanse of snow. The prompt guide for LTX-2 gives the necessary details. I am using the prompt directly. Let's see if it works with the smaller FP4 model. The way these prompts need to be described is given here. Establish a shot, then set the scene followed by describing the entire action, then character's appearance, and the camera movement. At last, there is the audio details. The details for different styles of video and the terms used for the style of videos are given here. The guide here I am sure will work with a full-size model. However, I am on an FP4 model, and the result may not be as we saw on the website. The prompt guide was lengthy, so I gave it to GPT, the entire text from the page. And then I asked for a different scene. You could ask what scene you are looking for. So I used the prompt given by GPT and generated a few 720p videos. And it looks good.
Watch your footing. It drops hard here.
This is insane. Don't slow down. This swell is perfect.
First wave's yours.
I increased the number of frames, made 241 frames for a 10-second video, and ran the workflow. 121 frames, which gives a 5-second output, used to take somewhere around 300 and 400 seconds. The video generation process is now completed, and the 10-second video took around 527 seconds.
This swell is perked. First wave's yours.
So, for a 10-second video, it takes somewhere between 500 and 600 seconds on my 4060 Ti 16GB. The FP4 model will work faster on a 5000 series card, so if you have it, then you can share the time taken to generate in the comments section. So that was the FP4 model. I will keep the details as it is and change the model with the FP8 model and see how it goes. The time shown here changed from second to minute, and it took 10 minutes, with some file compatibility messages. I tried for anime-style video, and the result was terrible. I then tried giving an image for reference with the anime-style prompt, but it didn't work either.
This light makes everything feel unreal!
Just don't lose your balance.
Next, I tried the image plus audio. This is the image uploaded, and here is an 8-second audio clip. The output resolution was set at 720 pixels, and this is the result.
5 months ago, I had a liver transplant. So I now have the liver of a mid-20s person who died in a car crash.
Adding an audio file with an image works. The workflow I am using is the default image to video workflow. And the files selected are the FP4 checkpoint with the FP8 text encoder. The VAE is used here to encode, and then the audio latent goes into both the stages of sampling for producing the final result. The prompt I have given here was simple, and this is the third attempt. I explained the image plus audio to GPT, and the prompt given by GPT did not work. The character was sitting still, with the speech continuing in the background. An extra file will be required in this workflow, which is selected here. You need to upload the audio file here, and this audio trim node allows you to use the specified part of the audio file. You just need to put the start and end timing of the audio file. Now the audio file used in this workflow will begin from the 3rd second, and you can listen to the trimmed audio in this node. Right now the audio goes directly from the audio trim node. But I should be using this model, which takes the audio and separates the vocals and instruments, so it becomes clear and decreases the chances of bad results. This file can be downloaded from here on Hugging Face. I'm using the smaller FP16 model from here. I will add a link to the page. You can get the file and keep it inside the Diffusion Models folder.
Okay, quick warning. I was generated by artificial intelligence, which means I am extremely confident and possibly very wrong. But
To generate the speech, I have used this Chatterbox voice TTS. And this is the script. The reference audio is given on the left.
why don't you just relax? That's right. And if it wouldn't be funny, then it would be sexy. Maybe a little exaggerated.
I ran the workflow, and the audio file in reference to the script should be generated in around 15 seconds.
Okay, quick warning. I was generated by artificial intelligence, which means I am extremely confident and possibly very wrong. But don't worry. I was trained on the entire internet, so statistically, I know everything.
So this was the result, which I have used in the LTX workflow. Now this is a 16-second file, and the video generated was 9-second. I tried generating a 15-second result, but the VAED code gave an error in the middle of the process. The TTS node I am using will be given in the workflow. You can use it directly by making a connection above. I'm using it separately. So that was it in this video. I will try the GGUF models and workflow now to see if it is any better. I hope this video was helpful, and have an excellent day.